Math students. All right, this lesson is going to be the first one in our series on how to solve equations. There's going to be a couple lessons that work together to show this complete skill, but we're going to break it down slowly, especially since this is probably many of your first time dealing with solving an equation. And in this chapter, we start small, so we start with really small equations that might seem simple on the surface, but this process that we learn is going to be used in almost every math class that you take from here on out until you're done with math, like in high school or even in college. So these are really, really big, important building blocks, so I hope you pay attention. And without further ado, here we go. We're talking about solving an equation. So I think the first question we should answer for ourselves is, what's the goal of when we solve an equation? What does that even mean? When you solve an equation, the goal is to find the value of x, or whatever variable you have, that makes the equation true. So for example, let's say you had an equation that said 3x plus 4 equals 52. So 3 times something plus 4 equals 52. When we look at the word solve an equation, when someone says solve the equation, what they're asking you to do is find out, what does x equal so that this equation is true? And there's only one value that will make this equation true. There's only one thing you can plug in for x that when you multiply by 3 and add 4, it will get you to 52. So when someone says solve the equation, what's the goal? The goal is to find the one value of the variable that makes the equation actually work. So that's what we're going to be doing this unit. The next question I think we need to ask ourselves is, well, how do you actually solve an equation? How do you, aside from sitting there and guessing and checking, which really is not going to work when the equations get more involved, how can I solve an equation? Well, the good news is there is a very clear process that you can follow that will work for every single equation that you face in your life. And that's what we're going to start looking at today. So to solve an equation, the first thing I want you to know is that if you're going to solve an equation, you need to be able to, let's look at this phrase, isolate the variable. What does it mean to isolate something? If you're isolated from the rest of the class, that means you're all by yourself. When we use this phrase, and you will hear it a lot in different math classes, when someone says to isolate the variable, that means you want to get x, the variable, all by itself. You want to get rid of all the other junk that's with it. So if we go back and look at this equation here that says 3x plus 4 equals 52, if someone told you to solve this equation, you need to isolate the variable, that means you need to get rid of the plus 4 and the times 3 so that x is the only thing that's by itself. And so what would be left over is x equals and then some number. So we got to get rid of all these numbers. So how do you solve an equation? You isolate the variable. And like we just said, that means getting the variable all by itself and getting rid of all the numbers and operations that are with the variable. So hopefully you understand what isolating means, but this brings about another question. Isolating the variable means getting it all by itself and getting rid of all the other stuff. How the heck do you get rid of all the other stuff? You can't just abracadabra make it go away. Well, there's a mathematical process that we use as mathematicians, that you will use as a mathematician to get rid of the stuff that's with the variable so that you can isolate the variable. In math, to isolate the variable, aka to get rid of all the stuff that's with the variable, we are going to use inverse operations. Read these words and get them in your brain, my friends. Inverse operations is probably one of the key things that works for every single equation you solve. You'll hear it so many times, not just from me, but whoever your next math teacher is and beyond. They're going to say, all right, what's the inverse operation? How do you inverse this out? To isolate the variable, we use this concept of inverse operations. Great, Mr. Carapezza, what the heck does that mean? How does it work for me? Okay, every mathematical operation has an inverse. Let's think outside of the math box for a second. What is the inverse of tying your shoe? Well, that would be untying your shoe. Undoing the tying part is untying it. What is the inverse of blowing up a balloon? Well, the inverse of that would be letting all the air out of the balloon. Everything has an inverse. Every mathematical operation also has an inverse. So let's look at two of the main math operations for this lesson, addition and subtraction. We'll do multiplication and division a different day. But what's the inverse of addition? Like, what's the reverse of adding something? If you're saying to yourself, subtraction, you're correct. The inverse of addition is subtraction. So if I had like x plus 3, the opposite of adding 3 is to subtract 3, right? If I subtracted 3 here, plus 3 and minus 3, those are opposites. Those are inverses. They just cancel each other out. Plus 3 minus 3 is just 0. So what would be left is x all by itself. So the inverse of adding something is subtracting it, because those are opposites, and opposites cancel each other out. What about subtraction? What's the inverse operation for subtraction? If you're sitting there to yourself saying addition, you're correct. The opposite of subtracting 4 from a number would be to add 4 back. Minus 4 and plus 4, these two things here, those are opposites. They're inverses of one another. Minus 4 plus 4, the net result of that is just 0. Those things cancel out. So if I wanted to get a variable isolated, and the operation I was dealing with was subtraction, I could get rid of the subtraction just by adding the same number, because inverses cancel each other out. Let's look at some examples of that. Look at the directions. It says isolate the variable. So I hope by now we know that isolate the variable means get the variable by itself. Get rid of the things that are with the variable. And how do we do that? We use inverse operations. All right, so example 1, x plus 7. I want to get x all by itself. Well, if I want to get x by itself, I need to get rid of plus 7. How do I get rid of plus 7? I subtract 7. Plus 7 minus 7, those are inverses. Those two things cancel out. And what's left over is the variable x all by itself. So we just isolated x all by itself. Now, we haven't solved an equation. We haven't gone that far yet. Baby steps, we're going to get there. This lesson is a pre-lesson to solving equations. We're getting the steps that we need, and we're going to put it all together in the next lesson. But for now, this is a very important concept. How do you isolate the variable? If you'd like to try this one on your own, you can pause the video and then see if you did it right. But how do you isolate y by itself when you have something that says y minus 3? So the inverse of minus 3 is plus 3. And minus 3 plus 3, since those things are opposites, they just cancel each other out. Minus 3 plus 3 is just 0. So those things are gone. And what did I just do? I got rid of the minus 3 that was with the y, and I isolated y all by itself. Isolated. Boom. Good. I've got 2 more for you. I'll go to the next one. So I've got 2.5 plus g, or if it's more comfortable for you to see the variable first, this is an addition problem, and for addition, order doesn't matter. Commutative property says you could rewrite this as g plus 2.5. So if you'd rather see it like that, that's fine. But these are the same expression. How do I get g isolated by itself? Well, what's the opposite? What's the inverse of plus 2.5? You got it, minus 2.5. 2.5 minus 2.5, those are inverses, they cancel out, And we have just isolated g all by itself. And remember, that's what the directions said. Isolate the variable, get it all by itself, and show how you did it. We're showing the inverse that we did. Seems silly, but you're doing big things. You'll see how it all plays together in our next lesson. Last example for this video, we've got h minus 1/3. Okay, how do I get rid of 1/3? I use the inverse. What's the inverse of minus 1/3? The inverse is plus 1/3. And these two things, since they are inverses of one another, they cancel out. The net of them is 0. Minus 1/3 plus 1/3, 0, gone, canceled out. And what's left over is just h. We isolated h all by itself. So in this video, we went through a couple of things. Number one was, what does it mean to solve an equation? That means to have the one solution that makes the equation true. We didn't actually solve any equations, but we talked about what it means to solve an equation. And then that led to the question, well, how do you solve an equation? To solve an equation, you have to be able to isolate the variable. And that means getting the variable all by itself. And then that led to the question, well, how the heck do you isolate a variable? How do you get it by itself? And that's the idea of inverse operations. We use inverse operations to get rid of numbers that are with variables. And we looked at two inverse operations today. The inverse of adding something is subtracting it, and the inverse of subtracting something is adding it. So you should be able to tell me what it means to isolate something, what an inverse operation is, and be ready to use this to solve equations tomorrow. You might have questions. Feel free to reach out if you do. Otherwise, happy mathing, people. I will see you next time.